On January 20th, two astronomers from this university, Caltech in Pasadena, Southern California, made an extraordinary announcement. They claim they had compelling evidence that a new, as yet unseen planet was orbiting the Sun, far beyond the existing planets.
So far, this is a theoretical discovery. The planet's existence has been predicted by computer models. But if it does exist, it throws up many questions. Where is it? What does it look like? And most crucially, how did it get there?
We'll be talking to astronomers here in California and in the UK to answer those questions and to find out what a discovery of Planet 9 would mean for our understanding of the solar system.
But first, let's put Planet 9 into context and see how it fits into our understanding of the rest of the solar system.
This is what we thought was the extent of the solar system for thousands of years. And it's restricted to the planets we can see with the naked eye. So in the centre, of course, we've got the Sun. Then Mercury, Venus, Earth, Mars, Jupiter, and 1.5 billion kilometres from the Sun sits Saturn. And this is all we thought that there was until the 18th century.
Since then, the solar system has gradually expanded. In 1781, Uranus was discovered, followed in 1846 by Neptune.
Tiny Pluto was added in 1930, bringing the edge of the solar system out to 5.9 billion kilometres away from the Sun.
Pluto was counted as a planet for over 70 years. But now we know it's just one object in a huge donut-shaped belt of billions of icy bodies and comets, called the Kuiper Belt. It was thought that the Kuiper Belt marked the outer edge of the realm of the planets. But now it seems that that might not be the case.
For some of us, it's an extraordinary thought. But many astronomers have long suspected there may be other planets lurking in the dark expanse beyond the Kuiper Belt. And we're getting the first evidence that suggests they may be right.
To get a feel of just how far away Planet 9 is, if it exists, we need to plot its position in relation to the rest of the planets. On this scale, every centimetre is about 35 million kilometres. The Earth is 150 million kilometres from the Sun. Pluto is 40 times further away, and the outer edge of the Kuiper Belt is still further.
But Planet 9 is far beyond that. At the point of closest approach in its orbit, it sits 200 times further from the Sun than the Earth. That's a whopping 30 billion kilometres away from the Sun.
But unlike the other planets, the proposed orbit of Planet 9 is not circular. Its highly eccentric path takes it much, much deeper into space. At its furthest possible point, its aphelion, it could be as much as 1,200 times further from the Sun than the Earth. On this scale, it's 54 metres away. In reality, it would be 180 billion kilometres from the Sun. And because the orbit is inclined by 30 degrees to the rest of the solar system, it means it's also above or below the plane of the rest of the planets. It seems almost unbelievable that there could be a planet so far out in the solar system. A mysterious world, 10 times more massive than the Earth. On an orbit so long, it takes between 10 and 20,000 years to complete one lap of the Sun.
But how was the discovery made? Chris drew the short straw and flew to California to find out.
One of the key people in the Planet 9 story is an astronomer here at Caltech, and he's got history when it comes to changing our views of the solar system. 10 years ago, he was instrumental in demoting poor old Pluto, and even wrote a book about it. His name is Mike Brown. Brown's speciality is the Kuiper Belt. In 2003, he discovered Eris, a Kuiper Belt object bigger than Pluto. A discovery that was instrumental in Pluto's demotion. A month later, he co-discovered Sedna. This was the first of what became 6 unusual Kuiperbelt objects that have been found with highly eccentric orbits that take them far out into space. They were 6 of the most distant objects ever found in the solar system. It was studying their orbits that led Brown to the idea that there might be another planet out there. So the story starts with the outer bits of the solar system, the Kuiper Belt.
What we found is that the most distant objects that are part of the Kuiper Belt, so these ones that come into the Kuiper Belt but swing out really far, the very most distant ones, if you look at their orbits, all of their orbits are pointing off in one direction instead of being randomly distributed around the sky.
So how tight is that alignment?
The ones that we know for sure that are aligned are 6 objects, and they're aligned within about 107-degree swath of the sky. It's something like this.
Yeah, okay. And it's not just the alignment in direction as well. The orbits have other things in common.
Well, so first you see the alignment in the direction, and then you realize that these 6 very most distant objects are also all tilted in the same direction, downward and a little bit to the side. They're within about 7 degrees of being in the same skewed plane as of each other. And the combination of those two is what really shows you that there's something strange going on. Because, you know, you could get the 6 of them lined up just due to chance. It's about a 1% chance you would get it due to chance. About 1%, you know, it's a small number, but it's not that small of a number. But if you take it also into the fact that they're tilted like that, that's another approximately 1% chance. So it's about 0.01% chance that this is all just randomly aligned.
So is that what got your attention and got you working on the problem?
That was the big clue that something is going on in the outer solar system.
This was an extraordinary finding. The tight clustering of the 6 orbits might have been caused by the gravitational influence of something massive in the outer solar system. For Mike Brown, the question now became what was out there and how could he find it? Working down the corridor from Mike is theoretical astronomer Konstantin Batygin. Mike and Konstantin have worked together for ages, and it always helps to have a friendly theorist on hand. And so Mike popped in to see if Konstantin could help with his problem. Konstantin's expertise is building computer models of planetary systems.
Hey, how's it going?
Yeah, nice to see you.
And
so Mike challenged him to build a computer model of the solar system that would replicate the strange orbits of the 6 Kuiper Belt objects. When you started looking into this problem of these strange orbits, I know that a planet wasn't the first thing you considered.
Indeed, yeah.
What else could have caused this effect?
We had a whole slew of explanations that we decided to look into first. You know, self-gravity of the Kuiper Belt, so the mass of the disk itself holding itself together in a coherent fashion.
All the bodies pulling on each other, essentially.
That's right, to create almost a fluid-like effect. As it turns out, the Kuiper Belt doesn't have enough material for this to be relevant. If it was 1,000 times more massive, that model would have some pull. We looked into whether or not a passing star could sort of perturb the structures and leave this long tail of orbits that we are now here to observe. Such encounters don't happen very often, and moreover, the alignment would go away over time, so this would have had to be recent.
And there's no sign of a very nearby star
That's right.
that's just done this.
That's right. So I think that's a very uncomfortable route to go.
And so, with all of that out the way, you start to think about planets.
We were careful to ensure that we're not chasing a red herring here, that this data is indeed real, the alignment is not some observational bias, it can't be a coincidence, all of that, before going down the path of introducing additional planets into the solar system.
When he started adding planets to his models, Batygin experimented with thousands of possible orbits, until he found one that replicated the strange orbits of the 6 unusual Kuiper Belt objects.
Suppose that the orbit of Neptune is about this big.
Okay.
Most conventional Kuiper Belt objects, Pluto included, have orbits that sort of hug the orbit of Neptune and are oriented every which way. But importantly, if you look at the whole Kuiper Belt from afar, it looks like a more or less axisymmetric disk.
Yeah.
This rule of thumb is broken when you look at the most distant orbits.
So these are the now famous 6.
That's right. If you look at the now famous 6, they all tend to swing out into the same overall direction.
So your simulations predicted a nice elongated, distant Planet 9 orbit.
Planet 9 is sort of a similar sized orbit, but it's facing the wrong way.
You might as well draw the planet on. Go on. We
That's
haven't
right.
seen it yet,
Yeah,
but
the
just
planet-
just for satisfaction's sake.
The planet, I am pretty sure it's in this part of its orbit.
Because otherwise we'd have found it.
We would have found it
Right,
otherwise.
okay.
That's
Fine.
right.
So there's our planet.
So there's our planet, and it's fascinating. Most of the time, the objects spend on opposite sides of the solar system. They're completely unaware of each other throughout most of their orbits. It's only when they come around at perihelion,
when they're closest to the
yeah,
sun.
when they go closest to the sun, they temporarily interact, and the mechanism, of course, is just gravitational interactions. And that's what maintains this lockstep alignment.
So every time they come round, they get this kick, or every 2 times, or
No,
whatever?
it gets complicated. For some orbits, it's every 33 times of this orbit per 19 times of
Okay.
this orbit. But fundamentally, it's not too different from tugging on something repeatedly in a coherent way.
Batikin's model had passed the first test. It had successfully replicated the orbits of the famous 6. But there was another unexpected effect. The model also predicted a second set of Kuiper Belt objects with even stranger orbits. Trouble was, they didn't seem to exist.
The biggest twist to the whole story came when our numerical models consistently would generate orbits that looked more or less like this.
So sort of coming in and out of the blackboard here.
That's right. They are on their sides. They're
Right.
perpendicular to the plane of the solar system. Right? And this is just so weird. You know, the fact that the simulation is producing these orbits that should be perpendicular and they should be readily observable, and the fact that we don't know of them is big trouble.
So it's not just that they might be there, they have to be there.
We initially thought of this as counter evidence to the existence of the planet. Fine, it explains alignment, but it also predicts stuff that's clearly not there.
This was the key moment where we looked at it and said, this makes no sense. But then I started looking more carefully at the other objects in the data set that I had not been paying much attention to in the last couple of years. There are 5 of these objects that are on perpendicular orbits that I remember when one of them was discovered a few years ago and thinking, that's just weird. Nobody had any explanation for them. And I said, Constantine, I'm going to go plot these right now, and we're going to see where they are. And if they're sitting right at these 2 spots right here, my head's going to explode. And we plotted them. One of them is right here. 4 of them are exactly right here where we predicted. And we just both sat there and stared at that. And I think my jaw hit the floor. It really was an honest, blind prediction of something we didn't know was there. And that when I look at those objects on those wings, and then I see those aligned objects too, I think I really am pretty convinced it's really out there.
If Planet 9 does exist, it would be a remarkable discovery. The first new planet to be found in our solar system in 170 years. That isn't to say it was completely unexpected, because there are places we have found planets that are similar to Planet 9. I went to University College London to meet exoplanet expert Professor Giovanna Tonetti. Giovanna, if Planet 9 does exist, it seems to have some very exotic characteristics compared with the rest of our solar system. In your work in exoplanets, have you seen anything similar to these characteristics out there?
Well, we're talking about an object that is about 10 times the mass of the Earth. These kind of objects are classified as super-Earths, which is a very exotic name. The NASA Kepler satellite tells us basically that these are among the most frequent objects in our galaxy. In fact, we didn't have any objects of this particular size, which was a bit puzzling in a certain sense. But if Planet 9 does exist, then of course we're ticking the box and we also have our own super-Earth.
So we had one missing, and now we look as if we've got one.
Exactly, exactly.
But Planet 9, if it's out there, is a whopping 200 astronomical units away from us at its closest approach. So that just seems an awful long way away. Have we got examples of planets that far away from their sun?
Actually, we do. And what you see now is GU Piscis b, which is located at 2,000 astronomical units from its star.
So that's the further reaches of Planet 9 potentially. Yes.
This is a real image, by the way. It's
Okay,
not an
no,
artist's
the
view.
fact you can actually take an image like this is amazing.
It's really very cool.
Okay, so we've looked at the size, we've looked at the distance from its local star, but now it's also a very eccentric orbit, and that seems quite exotic for our solar system.
It definitely is. Most of the planets in our own solar system are orbiting in orbits which are almost circular. But actually, out there, we are seeing planets that are orbiting in extreme elliptical orbits, and we have some example like this planet that is called the HD 806 or 6b. And as you can see from this picture, we have planets out there that are orbiting in very elliptical, what we call eccentric sort of orbit.
So if Planet 9 does exist, it isn't as exotic as we perceive it to be, because there's lots of other examples out there that are similar to the characteristics of Planet 9.
You're right, Maggie. And if Planet 9 were sort of proposed and discovered before extrasolar planet were found, probably we would dismiss this case, saying, well, this is way too eccentric, this is way too odd. We can't have a planet like this. And the fact that, on the contrary, now we know that planets like this can indeed exist is really making the case for Planet 9 even more interesting.
Well, thank you very much. It's been fascinating speaking to you.
It was a pleasure.
In theory, there's no reason why Planet 9 should not be out there. But there's only one way to prove its existence, and that is to directly observe the planet. Mike Brown took Chris to the famous Griffith Observatory to look at the skies above LA and to point out where he thinks Planet 9 is.
Okay, well, clear sky, sort of. Where is it? Where's this planet?
Well, we know its path across the sky. We know its orbit, so we know the path. And the path across the sky goes from somewhere over here, up across here, right through the middle of Orion and Taurus, and then down south across this way. And then, of course, all the way back around. We actually also know that around Orion and Taurus is where it's the most distant from the sun. And we think that's where it is. We think that the places that are closer to the sun, it would be too bright. We would have seen it already.
Okay, so in some sense you're already getting some observational data on the planet. You know where it isn't, and you know other things as well.
The other thing that we would know is that if it's too big, if it's the size of Saturn or the size of Jupiter, it would have been detected by the WISE spacecraft a couple of years ago. So they did a survey of the whole sky looking for things that move, and we now know that there's nothing as big as Jupiter or Saturn out to many, many times the distance of where we think Planet 9 is. So it has to be small, meaning the size of Neptune or maybe a little bit bigger, and it has to be pretty far away still and somewhere off in here.
And pretty faint. Otherwise, I mean, we're not talking amateur telescopes here to find this.
No, in the end, it's going to take us some time on the biggest telescopes in the world. But with the biggest telescopes in the world, it is well within range, and we'll be able to find it.
It'll be exciting.
Yes.
So I know you're looking for it. Lots of other people will as well. I'm sure they will now.
Yeah.
Does it bother you who's going to find it?
I would love to find it myself. I would love to have that moment, which I've gotten to have before on these big objects in the Kuiper Belt with Eris, where you see it, and for a moment, you are the only person in the history of humanity who has seen this object so far away. I would love that. I will not lie. At the same time, I want it to be found, and so if somebody else finds it first because they were searching hard for it and helping us out on this search, yes, I will feel, just my heart will sink a little bit, but I think that'll be overcome by the fact that I'm so excited that it was found.
It's up there somewhere, probably.
Right there.
One of the big questions about Planet 9 that we will have to answer if people are to take the claim seriously is, how did it get to its current orbit? To get to the bottom of that question, I've come to Queen Mary, University of London, to meet Professor Richard Nelson. Richard, what's the problem with the proposed orbit of Planet 9?
Well, it's very difficult to form a planet on an orbit like that. And we believe, according to current models, that it would take almost the age of the solar system itself to form a planet all that far out.
Because it has to accrete onto the body?
That's right. So the accretion process, which brings small agglomerations of material together and builds larger and larger objects, leading eventually to a planet, all the way out there just takes far too long because it's moving around very, very slowly, and there's a very low density of material there as well.
So if it didn't form out there at the outer limits of the solar system, where did it form?
Well, our best guess is that it probably would have formed among the existing giant planets, Jupiter, Saturn, Uranus and Neptune. So there are theoretical models already which indicate that if you run computer simulations of the early solar system, its evolution, and you have a dynamical instability, having a fifth planet there actually helps those models reproduce what we see in the solar system today.
So that fifth planet could be Planet 9?
Could very well have been Planet 9, which is no longer there, but orbiting further out.
So what are we seeing here?
What we're seeing here is a computer model of the early stages of the solar system, but with 5 planets. So we've got the white planet there, that's Planet 9. The other planets, Jupiter, Saturn, Uranus and Neptune. You'll see the planets are going around essentially on circular orbit.
As you'd expect.
As you would expect, that's right. They're all interacting, they're all perturbing one another. But Planet 9 in this simulation is a little bit too close to Saturn when it starts. At some point, we're going to see it have an encounter which gives it quite a dramatic little kick, and you'll see it change. There you go. So yes. That's right. So you see that. And this keeps going on and on and on. Jump forward, you can see the planet's orbit has expanded a lot. And there you have a very eccentric and a very inclined orbit.
So does that do it? Does this give us the orbit of Planet 9?
Well, unfortunately not, because Planet 9 has an orbit where the closest approach to the Sun is about 200 or 300 astronomical units away. So, as you will have seen here, Planet 9 keeps coming back into the inner solar system and continues to interact with the giant planets there. Eventually, one of those encounters will be strong enough to throw it out of the solar system altogether.
But how can you stop it from pinging off out into the galaxy?
Well, I think if Planet 9 is actually proven to be there, it's going to tell us something very interesting and very important about the origin of our solar system. So, what we've looked at so far is a solar system forming in isolation. But now let's imagine that the solar system formed within a star cluster. If we look out within the galaxy, we see that stars do tend to form within groups and within clusters of stars. If Planet 9 was thrown out onto one of these very, very eccentric orbits while the star cluster was still there, then gravitational perturbations from the star cluster could have caused Planet 9 to change its orbit when it was at its most distant position from the Sun. So I have a simulation which shows that here. When it goes out on this orbit this time around, it's not going to come back in anymore.
Right.
There's going to be an interaction with a nearby star, which changes the shape of the orbit, just like that.
So suddenly it expands outwards and stops going back into the inner solar system.
So that's what saves it from being ejected from the solar system.
So a lot of your model does seem to tie in with the evidence we're seeing for Planet 9. It could explain the sort of the huge orbit, the inclined orbit, and why it's still there and not out there in the galaxy.
That's right. That's why I said at the beginning that I think proving that Planet 9 is present within our solar system with the orbit suggested would also indicate very strongly that our solar system didn't form in a lonely place but was part of an earlier star cluster.
Pretty fantastic stuff.
Wonderful.
Thank you. It's been fascinating.
Pleasure.
And that leaves one final question. What sort of planet is Planet 9? And what are the conditions like so far out in space?
At the far reaches of its orbit, the Sun would appear tiny, just a point of light.
But it would still be the brightest star in the sky. Although the Sun would be 1,000,000 times dimmer than it is here on Earth, it would be 1,200 times brighter than Venus appears to us.
That far from the Sun, it's very cold. Some estimates have suggested it could be below minus 250 Celsius.
As for the qualities of the planet, we don't really know. The computer models suggest it should be 10 times more massive than Earth. But it could take different forms.
One possibility is that Planet 9 could have been ejected from the inner solar system early in its development, when it was just the core of a giant planet. This would make it predominantly rocky and icy. Now, with 10 times the mass of Earth, it would be twice the diameter, and it would probably appear to be a dark pinkish red in colour. But if the planet was ejected when it was more fully formed, then it would have a chance to build up to the gassy layers like Neptune and Uranus. Then it would be much less dense and so bigger, maybe 4 times the diameter of Earth.
It's thought the planet may have an atmosphere rich in hydrogen and helium. In these cold temperatures, it's likely it will appear as a bland, featureless sphere. Unless the planet is still producing some internal heat, in which case we may see structure in the atmosphere. Clouds of methane ice, ammonia, and even water ice.
It all seems so exciting, and yet, despite the possibilities, so far Planet 9 is no more than a prediction in a computer model. and they've been proven wrong before.
So, very unscientific question, but the one that keeps coming up. How sure are you that this exists?
Oh, 1 quadrillion %. So you got an unscientific question, but a scientific answer right back at you.
But as a theory, you believe your models, right?
Actually, we try very hard not to believe our models. But look, if this thing is not out there, right? If the search comes up empty, then the outer solar system has some really, really substantial explaining to do.
And you've ruled out the other explanations, right?
At least for me, it is difficult at this point to argue for a solar system that makes sense without Planet 9.
Mike, what about you?
So I'm slightly lower than a quadrillion %. The human brain is really good at seeing patterns. And when I can't sleep at night, it's because I'm worried that we saw a pattern and made up an explanation. And then as more observations come in, the pattern disappears. I don't think it's going to happen. I'm actually very convinced. But that doesn't mean that I sleep all through the night.
I sleep all through the night.
Yeah.
I am really eager to see it, to confirm it, to learn what it's like, to see if it has moons and rings, and I just want to know all these things.
And do you have any sense of what that will feel like?
You know, I bought a cigar about a year and a half ago, and it's still sitting in my desk. And I'm, you know, every time that something dramatic happens, I always forget to smoke it. So maybe I won't forget that time.
You know, I'm gonna go buy a good bottle of champagne, and I'm gonna put it in my office. I'll put it in the fridge in our office, so keep it cold. And when it happens, we're just gonna drink it right then.
And between now and the cigars and the champagne, while we're waiting for the discovery, what are you two working on next?
We are looking for the planet, but we're also looking for more of these objects that are aligned, that are perpendicular, that aren't aligned or aren't perpendicular, to prove ourselves wrong. You know, if anybody's going to prove us wrong, we would rather do it ourselves than to have somebody else do it. So we are trying very hard to prove ourselves wrong.
It's an exciting time.
It is. Let's hope it gets more exciting. Thanks a lot.
Thank you.
Today's been incredibly exciting. The team's belief in Planet 9 is contagious, and I've become increasingly convinced that it really is out there somewhere in the outer wastes of the solar system. I'm sure I'm not the only one. There will be teams and telescopes from across the world racing to be the first to see it. And if it's found, when it's found, it will be the astronomical discovery of the century.
That's it for this programme. But don't forget to check out February's Star Guide on the website. Next month, we'll be looking at the top 5 photographs of the solar system ever taken. But in the meantime, get outside and get looking up.
The sun is tilted by 6 degrees with respect to the plane of the planets. The reason for the non-zero solar obliquity has been a mystery since it was first discovered by Sir Richard Carrington in the mid-1800s. It turns out that Planet 9 can actually tilt the sun.
The fact that the sun is tilted, even if it's only by 6 degrees, the fact that the sun is tilted, you know, the sun is the most massive thing in our solar system by a huge margin, and it's oriented differently than everything else in the solar system. That is an incredibly strange phenomenon for which there really have not been that many explanations even attempted over the last 150 years. It's naturally explained by Planet 9 being exactly where we think Planet 9 is, which it's one of these mysteries that we think is now solved, that's been such a mystery that people haven't even really talked about it very much over the last 150 years because it's just been so difficult to think of why it is.
It has been known since the mid-1800s that the sun is tilted. Over the years, people have put forth various explanations for it. One possibility is that the sun was interacting with the protoplanetary disk via magnetic fields. It's also possible that the disk was just asymmetrical from the beginning. And it's also possible that the sun actually had a stellar companion a long time ago.
It was a moment of inspiration. Not all projects start out this way. Not all results really come. Some of them come, you know, it slowly dawns on you. We were sitting in Konstantin's office one afternoon, and we were actually thinking about a different problem entirely, which is how Planet 9 would interact with these very distant objects in the Kuiper belt that made us originally think that Planet 9 was there. And in just a moment, as we're thinking about it, and we're doing this with our hands, trying to think of directions things are going, I think we both realized at about the same time. It's like, oh, it's going to make the sun look tilted too. And it was very clear from the way we did our fingers that it was going to make an effect. What we didn't know until we did the calculations was how much of an effect was it going to have and in what direction was it going to go. But we knew it had to do something.
Planet 9 has been scattered out into the distant solar system. So because it has an orbital period that's so long, it has an enormous amount of angular momentum, right? As much almost as the rest of the solar system combined. So even though as an object it is not as massive as Jupiter, it has a huge lever bar. Okay? And using that lever bar, it can effectively torque the rest of the disk of the solar system by 6 degrees over the age of the sun.
Next, always next on our list is find the planet. We think we have it narrowed down to a pretty small patch in the sky that we have to look at. Small patch in the sky still means we need many, many nights on the telescope. We're pretty convinced that by maybe the end of next winter, we will have been able to cover enough sky that we'll actually be able to find it. When we find it, we both show that
we've created this new Planet X Special Report series to address the fear, uncertainty, and doubt, or what's known as FUD, that's out there on the internet today regarding Planet X. We have been researching in this field of space threats since 1999. And what we see is that much of this FUD is artificially engineered by disinformation operatives who, in our opinion, are well organized and very well funded. Another question we do get from folks is, what would a Planet X flyby look like? In our February 2009 video report, we offered 8 different flyby scenarios, ranging from a rather mild best-case scenario to a devastating worst-case scenario. However, regardless of which of these scenarios may come to pass, we have already seen what a Planet X flyby will look like in part. September 2009 shall be forever remembered as the month we added a new term to the lexicon of catastrophic Earth changes, the Sydney-style dust storm. On September 22nd, Sydney, Australia, and its adjacent communities were blanketed with dust from the red soil blown in from the western regions of the country. As you can see in this comparative of the Sydney Opera House, the clear, beautiful blue skies of this modern city were choked with a blinding red dust that blocked visibility. It forced the young, aged, and infirmed to remain indoors, while the many commuter ferries that crisscross Sydney's bay each day with work-bound commuters were forced to remain idle at moorings. This storm was first brought to our attention by a Yowza subscriber, Sharon, who lives in a bedroom community adjacent to Sydney, due east of the city center. She sent us these photos she took from her home, looking out her bedroom window. No matter what scenario is involved for Planet X, this is one of the things we'll see with each and every one. Ladies and gentlemen, Planet X, 2012, and catastrophic Earth changes are no longer an issue of idle speculation or entertainment. Rather, it is about you, your loved ones, and whether or not you choose to fight for your lives. If you're looking to our leaders for answers, know this: they're part of a system of political and corporate elites with their own agendas that may or may not coincide with our own. Nonetheless, these very different agendas provided us with valuable new information in 2008 and 2009 that corroborates our original Planet X orbital forecast. We saw the onset of a massive disinformation campaign, and the goal of this campaign was to lead people down unproductive rabbit holes so that they would become discouraged and leave the topic. Well, it's not working for them. And in fact, what we did find was rather valuable information. To understand that, we need to start with their principal attack method, what we call the ecliptic false positives. The best way to visualize the ecliptic is to start at a point in the center of the sun and then go out in a flat plane from there through the known planets and moons of our solar system, and finally on out to the 12 constellations of the zodiac. This is what we call the ecliptic, the plane of our solar system. Above the ecliptic are the northern skies. Below the ecliptic are the southern skies. For the purpose of this program, we need to replace the designations of east and west, so to speak, with towards the center of our solar system and out to the edge of the solar system. The ecliptic is an important concept for understanding where Planet X is presently in relationship to our Sun and to using these ecliptic false positives. The first ecliptic false positive surfaced in early 2008 with the missing Orion star panels, as reported by YouTuber No Star Panel on our site. Powerful disinformation groups had managed to corrupt the celestial databases of 3 major sky viewing websites. The purpose was to mislead the public by falsely drawing their attention with planted information along the ecliptic and out beyond the edge of our solar system. Towards late 2008, this scam sputtered out, and disinformation wolf packs began pushing people in the opposite direction, towards the center of our solar system, with a new scam. We call them the bogus cell phone sundog photos and Soho red herrings. By early 2009, the public began catching on to these scams, and citizen journalists on YouTube began debunking them. We cannot begin to tell you how pleased we were to see this. It reminds us of that great quote from the American President Abraham Lincoln. You can fool all of the people some of the time, and some of the people all of the time, but you cannot fool all of the people all of the time. Ladies and gentlemen, you're not sheeple, and you're not buying these disinformation scams, and the operatives and those who employ them know it. Consequently, we're now seeing a new wave of reckless disinformation and propaganda non-event predictions designed to create more fear, uncertainty, and doubt, and thereby disinterest the public. So beware. That being said, these disinformation ecliptic false positives we've just discussed have given us information of great value. It is because now we know where not to look for Planet X at this time. Rather, we need to keep looking where we have always looked, towards the southern skies. Not just because this is the very part of the sky disinformation wolf packs want to turn us away from, but also this is because where the available science we're reporting on our site continues to point. So with all this in mind, let's see if we can cut through this malevolent fog and take a look at where we believe Planet X could have been in September 2009. What the disinformation, ecliptic false positives of 2008 and 2009 show us is that we were pretty much on the money right from the get-go. We published our book, Planet X Forecast and 2012 Survival Guide, with an estimated orbit for Planet X through 2014. Prepared by Dutch physicist Jaco van der Warp, it shows Planet X approaching the core of our system from the south. We will present 2 slides prepared as an update for this report by Jaco van der Warp, showing where he estimates Planet X to be as of September 2009. Please note, I will be using the term astronomical unit, or AU for short. An astronomical unit is the approximate distance from the Earth to the Sun. For example, the Earth orbits the Sun at a distance of 1 AU. Jupiter, on the other hand, orbits the Sun at a distance of 5.2 AU. Or in other words, it is 5 times further away from the Sun than the Earth. Now let's take a look at our first slide. In this slide, you can see the orbital path of planet X, which is steeply inclined to the ecliptic. Yakko currently estimates the distance between planet X and the Sun to be 9.9 astronomical units. Now let's imagine we're standing on the South Pole. Here is slide number 2. Here we're looking above the horizon at an angle of approximately 60 degrees, and planet X is in the constellation Pictor. Now let's address the 5 reasons why we're not seeing planet X at this time. We know planet X has been here before, and we have the ancient accounts of the Sumerians, Egyptians, Celts, and many more. They've all given us various different descriptions of the object. For example, in the ancient wisdom texts we publish called the Kolbrin Bible, the ancient Egyptians called it the Destroyer, whereas the ancient Sumerians called it Nibiru. Consequently, there are a lot of different ideas as to the nature of this object. In our February 2009 report, we discussed 3 possible variants: an asteroid-like object, comet-like object, and mini-constellation. Until planet X is officially observed, it could be anything, although we do know it is big. Otherwise, it would not be interacting with the other bodies in our system as it does. Each of these 3 variants has its own observation peculiarities, and these are exacerbated by the fact that this object is in a comet-like orbit. Regardless of what type of object planet X turns out to be, one thing we do know is that it is in a comet-like orbit, and that makes it very unpredictable. A good example is comet Hale-Bopp. It was the most widely observed comet of the last century, and it was dubbed the Great Comet of 1997. At the time of its discovery in 1995, it was estimated to be in a 4,200-year orbit around our Sun. However, in 1996, it passed within 0.77 AU of Jupiter. To help put that in perspective, Venus orbits our Sun at a distance of approximately 0.72 AU. So, as a result of a 0.77 AU flyby past Jupiter, Hale-Bopp's 4,200-year orbit was shortened by 40% to just 2,533 years. How could this happen? Just as with planet X, Hale-Bopp's orbit around our Sun is steeply inclined to the ecliptic, which makes it inherently unstable. And the substantial reduction in its orbit is explained by a theory called the Kozai mechanism. You can learn more about the Kozai mechanism on the internet, and it is covered extensively in our book Planet X Forecast and 2012 Survival Guide. As we've often pointed out in our book and on our websites, this object is in an unstable comet-like orbit. Simply stated, Planet X is a fast traveler, and its orbit is steeply inclined to the ecliptic. Ergo, its orbital behavior is highly unpredictable and subject to change at any time. This will become even more pronounced as Planet X closes the distance between itself and our Sun. The closing distance between Planet X and the Sun is very important for us to consider. Now let's take another look at that first slide prepared by Jaco van der Warp. He currently estimates the distance between Planet X and the Sun to be 9.9 astronomical units. That is nearly twice the distance between Jupiter and the Sun. This is an important fact because comets are not typically observed until they're inside the orbit of Jupiter. They must come this close to the Sun before they develop a coma and tail. This in turn helps to also explain why Planet X is going to be difficult to observe at this time, assuming it is a comet-like object. To help give us a perspective on the Planet X transit through the southern skies, let's return to Jaco van der Warp's second slide. When we presented the second slide, the one where we are looking from the South Pole out into space, we're doing so at an angle of approximately 60 degrees up from the horizon. When we do so, our estimate places Planet X in the constellation of Pictor. The arcing line of the orbit suggests that Planet X will follow a steady, plodding course as it moves from left to right towards the constellation Vela. However, this is not the case because of two reasons. First, the manner in which the Earth rotates on its poles as it relates to our view of the night sky. And secondly, because Planet X is in a comet-like orbit that is steeply inclined to the ecliptic. We therefore estimate that by August 2010, Planet X will enter the constellation of Carina, where it will begin to speed up a bit, as is the case with comet-like orbits. During this time, the distance between Planet X and the Sun will be decreasing, while at the same time the angle of its orbit will be increasing. This decreasing distance and increasing angle will continue and even speed up as Planet X approaches the ecliptic. Assuming Planet X continues following this orbital path, regardless of what type of object it may be, the fact is it's going to be heading towards the Milky Way, and that creates a whole new kind of viewing problem. When viewing an object in the night sky, you must be able to differentiate between it and the star field behind it. To illustrate the complexity of this, let's assume that you are going to a candlelight vigil to meet a friend. You know what your friend looks like, and you know he or she will be holding a candle. But when you arrive, spotting your friend becomes a very difficult proposition. The same holds true with Planet X. At this time, it is about to pass through the most magnificent candlelight vigil, if you will, in our night sky, the Milky Way. With that in mind, let's return to our second image of the South Pole view. Here we see Planet X slowly making its way along its orbital path towards the constellation Vela. In this slide, we are showing you the position of Planet X relative to the South Pole point of view. Now, let's take the same panel slide and increase the brightness. The light gray area that runs through the right side of the image from the constellation Bella down through to the constellation Canis Major is the Milky Way. So not only is Planet X twice the distance from our Sun as Jupiter, it is passing through an area of the sky that receives less than 2% of our attention, and one with a very dense background star field at that. Ergo, what you've got is the proverbial Planet X needle in a cosmic haystack. So who will officially announce the discovery of Planet X? Certainly not some run-by fruiter with a cell phone. Rather, we believe that honor will most likely go to Project Wormwood, a planetary defense group at the Learmonth Solar Observatory, located on the northwest cape of Western Australia. Now let's move on to the most likely, worst case Planet X flyby scenario. This is the difficult part of this video briefing for us as Planet X researchers, because we really do understand how these various different Planet X flyby scenarios could work out. I can remember back in 2002 and 2003 when I was making guest appearances on Coast to Coast and saying clever things like, the surface of the Earth could wiggle like a bowl of jello. With a comfortable distance of time, such clever radio sound bites were all too easy. Yet as clever as they were, perhaps it turns out they could be closer to what may happen than I could have imagined. In February of this year, we published a report with 8 different flyby scenarios, ranging from the best case to the worst case. I strongly urge you to view that video if you have not already done so. In this video briefing, I'm going to take a look at what could be a likely worst-case scenario. I want to strongly emphasize to you before I do this that there is no true likely worst-case scenario. This is an unstable object, it's a fast mover, and things could change at any time. I want to strongly urge you, the viewer, to understand that when Planet X crosses the ecliptic, you will go into an area we call the kill zone. We fully explained the kill zone in our February 2009 report. For now, what we need to keep in mind is that this is when the worst case, or the best case scenario for that matter, will occur. Assuming there can only be one best case scenario and likewise one worst case scenario, the odds of one of the other happening is 50-50. This is because a best case scenario can only happen if Planet X passes through the kill zone while it is on the side of the Sun opposite from Earth. However, if Planet X passes through the kill zone while it is on our side of the Sun, then that is when the most likely worst case scenario will occur. As we have stated in this video and countless other times, this object is a fast mover in a comet-like orbit, and it is unpredictable. So a definitive estimate as to whether we'll have a best case or a worst case scenario is virtually impossible. Even if we could somehow manage to connect all of the computers in the world together to form one massive computing machine, it would be hard-pressed to better our 50-50 odds at this time. Because of these limitations, the best we can do now is to prepare for the worst and hope for the best. And there's only one way we can really do that at this point in time. We must look beyond the limits of traditional science into a realm of inquiry where we take into account prophecies from the Holy Bible, Mother Shipton, Nostradamus, Leonardo da Vinci, and many others. Taken all together, what we see is a recurring pattern consistent with the pole shift prophecy of the sleeping prophet, Edgar Cayce. With this in mind, we've watched the trailers for the forthcoming 2012 movie by Sony with great interest. While there is nothing in the trailers to explain how these events come about, what we see as Planet X researchers is very clearly an Edgar Cayce pole shift. So if you really want to know what the worst case scenario would be, then go watch the movie. And yes, keep in mind it is Hollywood, and that they are taking creative license, and that they tend to exaggerate things. However, when we look at it, at least from what we see from the trailers, it's a spot-on Edgar Cayce pole shift, complete with mega tsunamis, superquakes, and supervolcano eruptions. One thing we've noticed with Sony's 2012 movie trailers is that they open with this really ominous 2012 Mayan prediction. Well, the Maya were telling us something much more than that. Yes, it's the end of an era, but it's also the beginning of a new era. And let's keep that in mind as we look at what could be a possible worst-case scenario for 2012 and beyond. Our book, Planet X Forecast and 2012 Survival Guide, was written with one very specific audience in mind. Not dabblers, not those who are curious, but rather we wrote it for people who get it and want to get through it. And for that reason, we've listed out the various catastrophic threats. Well, topping that list is solar violence. Even if, for the sake of argument, Planet X was completely taken out of the picture for 2012. Are there still threats? Are there still concerns? Well, yes, there are. And you should be very concerned, because our current solar cycle will reach its maximum in 2012. And if what the scientists are telling us holds true, that's when all hell breaks loose. So what will all hell breaking loose look like in 2012? Well, we have a historical model for that. It's called the Great Storm of 1859. In an article published in October 2003 on Space.com, science writer Robert Roy Britt takes us back in time to 1859. Simply put, this solar storm remains the most violent ever recorded in American history, and it was 3 times more powerful than anything we've ever seen since the end of World War II. However, in 1859, the state of technology was primitive. It was mostly telegraph lines running through both America and Europe. These telegraph lines shorted out during the storm of 1859 and consequently ignited numerous widespread fires on both continents. Not only that, in Hawaii, they reported seeing the aurora borealis. Of course, this begs the question, if a solar storm such as the one that struck the Earth in 1859 were to strike today, what would that mean for us? Once again, we turn to the author, Robert Roy Britt. In an article written for Fox News in January 2009, Mr. Britt examines the implications of an 1859 event happening today. Britt tells us in this article for Fox that should another storm as powerful as the one that hit America and Europe in 1859 hit us again, particularly in 2012, it could shut down the United States for months. This according to the National Academy of Sciences, which has also expressed the opinion that there is a very great likelihood of another such storm occurring in 2012. So what would that mean? Well, just in the United States alone, 113 million Americans would find themselves in a blackout. Not one lasting a few days, but rather a blackout lasting several months. This is totally consistent with a 2012 warning given on Fox News by physicist Dr. Michio Kaku, as noted in our February 2009 report.
Satellites, satellite television, all of that could get disrupted, peaking around 2012.
So your point is we can't do anything about it in space, but we can do something back here on Earth.
That's right.
But backup systems, are companies really doing that?
Well, they're going to have to do it because, see, we scientists made a mistake.
Now, before we move on, I want to make one thing perfectly clear. We are not glorifying Fox News here. As a matter of fact, the news entertainer, I don't call them reporters anymore, the news entertainer that interviewed Dr. Michio Kaku has a new formula. 2012 equals Y2K. You know, the millennium bug. Well, that begs the question, where are you at with all this? Are you saying, I'll believe it when I see it? And if so, let me ask you this. What are you going to see when the whole nation is blacked out for months as the result of a violent solar storm. While you ponder that, let's move on to the closing thoughts for this video briefing, and that being what we believe to be the greater significance of 2012. When we first began researching Earth changes, space threats back in 1999, and then later moving into Planet X research in 2001, we really didn't see 2012. It simply was not on the radar scope. However, as the years passed and the data came in, we began witnessing this incredible convergence upon this 2012 date. A breathtaking convergence, one comprised of science, history, prophecy, and human evolution. And at the point of it all was the Mayan calendar. The essential message of the Mayan calendar, the one that is accepted by all those who debate it from one side or the other, is that the prophecy represents the end of one era and the beginning of another. Therefore, looking at December 21, 2012 is not about assuming that a cosmic intelligence or deity or whatever you happen to believe is going to throw a big switch on that day, and then something humongous is going to happen. As Planet X researchers, it is just a waypoint for us. That's all. But I would hasten to add that it is a significant waypoint. It is significant because it will be a defining moment in time, like December 7th, 1941, or 9/11. We believe that 2012 will be remembered as a year of redemption, a time when humanity is forced to examine its foibles and to realize that we have not been good guardians of this world. And at that point, we are going to face a destiny decision, and one that is best described for us by the Hopi Prophecy Rock. The Hopi Prophecy Rock is centuries old, and it tells us that if we continue along on our present path of service to self, based on greed, fear, and exploitation, then we will become a slave species for countless generations to come. And only until our world has been so brutally raped that it is of no interest to anyone will we be given our freedom for whatever time remains. But if we redeem ourselves and choose the service to others path, what happens then? Well, something beautiful. This other path will lead us in a direction of compassion, coexistence, tolerance, and a loving respect for each other and our world. Should we find the courage to make the wise choice, to take the noble path, where will it lead us? To a bright future. The generation that follows 2012 will be the most important population of humans in the history of our species. They will lay the groundwork of the future. They will rebuild. They will move on, and consequently our descendants will make their ways to the stars. There they shall not number in the billions as we do today, but in the hundreds of billions. And it will be a bright and enlightened future for our species. So imagine with me for just a moment this distant future, and assume that you are one of our future descendants, grateful for our noble sacrifices, and looking back in time at the year 2012, the year of redemption. How will you remember it? Well, for us, 2012 will be the last year of this era, and likewise we'll have 2013 and 2014 and so on. However, should we choose the noble path shown us in the ancient Hopi Prophecy Rock, the future generations will look back upon the year 2013 by another name. They will call it 1AE for the first year of the Age of Enlightenment. We at Yowza.com do all that we do because we're in it for the species, and because we do believe that humanity will make the wise choice. We will take the noble path, and there will be a 1AE. And I'll leave it on that note. So until the next time we meet, remember Marshall's motto: destiny comes to those who listen, and fate finds the rest. So learn what you can learn, do what you can do, and never give up hope. And this is Marshall, and I'll catch you on the backside.